Welcome to Straight Science, everyone. Straight Science is an evening science seminar put on by University of Alaska Northwest Campus, as well as University of Alaska Fairbanks Alaska Sea Grant. So both Northwest Campus and Alaska Sea Grant, we are servants of the Bering Strait region. Bering Strait region is the homeland and waters of the Inupiaq, St. Lawrence Island Yupik, and Central Yupik peoples. And I looked up, tonight's going to be, we're going to talk about the Bering Strait region, but also Rick Thoman's going to talk a little bit more about the southeast of Nunivak, where our neighbors to the south just were impacted by the ex-typhoon that we were supposed to get. So we're all interested in hearing more about that. Rick Thoman, really no need to introduce him unless you don't know if you're online, but Rick Thoman is the climate specialist at the University of Alaska Fairbanks Alaska Center for Climate Assessment and Preparedness. They have changed the P part of their name from policy to preparedness. So Rick will lead it off, and in 13 years, I think, of Straight Science, you have presented. This will be your 17th time. So as well as dealing with the Nome Nugget and being accessible, you also provide Straight Science. So we are eternally grateful. I think the whole region is really behind you and thankful for what you do with the weather forecasting and looking out for our region. Then bringing it home will be Anjali Shah. She is a fellow at the University of Alaska Fairbanks Alaska Center for Climate Assessment and Preparedness. You can always guarantee the university has lots of words for everybody. So that's good. And she will be giving us an overview of extreme events and coastal flooding and something near and dear, harmful algal blooms, which we are all interested in as well. So with no further ado, we'll have Rick lead it off. Questions will be after Rick provides an update on how long. And we won't go too far into that until after Rick's other presentation, and Anjali also gets to give her bit. So we're looking forward to both presenters. Take it away, Rick Thoman. We are so glad you and Anjali are here.
All right, great. Thanks very much, Gay. Thanks everybody online and in person. Yeah, so when I sent Gay the, what are you going to talk about this? This was in late September, and Halong was not in the picture. So given the impacts in Western Alaska and the threat that it sure looked like it posed to the Bering Strait region, I thought it would be worthwhile and of interest to folks to cover a little bit. So the summer recap is a little bit shorter, and Halong is here now. So let's go ahead and jump right in.
Oh, for some reason, we are not seeing your presentation. Is the audience seeing the presentation?
We see it online. We do.
Okay, you do. All right, keep going. Sorry, Rick.
I'm attempting to advance. Let's see if that, okay. See if maybe that'll work. Okay, so here's the agenda. I'm going to talk about Halong a little bit here, and then we'll take a few questions. If there's something burning that isn't clear you want covered, we'll take a few questions then. If not, we'll go into the summer recap for the region, and my part will end up with the winter outlook, and then Anjali will talk about her work with ACCAP's Extreme Events Library and some of the things that she's working on that are particularly relevant to Nome and the Bering Strait region. All right, so Typhoon Halong formed southeast of Japan on October 5th. This satellite picture there was near Halong's maximum intensity. Unlike Merbok, which was barely a typhoon, Halong was actually a severe typhoon. And you can see on the map there, it's not very far south to east there at its maximum intensity of Japan. And it did cause significant damage to some of the islands east of Honshu there. And it was notable for its very rapid, it formed on October 5th, and about 36 hours later, late on October 6th, it was a Category 4 scale strength typhoon. So very rapid intensification. Then it turned northeast on October 8th and started heading east-northeast across the Pacific Ocean, and it lost those tropical characteristics on October 10th. That's when, like, the Joint Typhoon Warning Center in Guam stopped tracking it. Japanese Meteorological Agency put that to bed. However, at that point, it was on the way to Alaska, moved into the Bering Sea on the morning of October 11th, and then moved very quickly to the northeast, and it was over the Beaufort Sea by the evening of the 12th. So really, really on the move. So I talked about this after Merbach too, and I've gotten lots of questions in the last week about, is it an X typhoon? What's this X mean? Why isn't it just a typhoon? So here's the explanation. When we talk about typhoons, hurricanes, tropical storms, that's really a meteorological jargon term because it refers to the source of the energy that's driving those storms. In the tropics, that comes from very warm ocean waters. And so if you have a storm that's deriving its energy, extracting energy from very warm ocean waters, and at some part of the storm at least has sustained 39 miles an hour winds, it gets a name. There are somewhat less than 100 storms annually around the world that meet that criteria in all the tropical basins put together. Now, storms that extract their energy from horizontal air temperature differences, that's how storms form in the mid and high latitude. There are, of course, thousands of those storms every year in the northern and the southern mid and high latitudes. And conventionally, they don't get names. Now, that's been in Europe, they have started naming storms that reach some particular threshold that are not tropical storms. Some private companies in North America do that, but in North America, government agencies still don't do that. So X means that a storm began its life cycle deriving its energy from warm tropical ocean waters and then transitioned to that air temperature difference as the fuel for the storm. Now, that might sound like a very technical, geeky distinction, but in fact, it's really important. It's really important for Alaska because as a tropical storm, as a storm that's deriving its energy from the ocean, as it makes that transition, the wind field expands greatly. So you have strong winds over a much larger area than you do when it was a storm extracting energy from the ocean. So that transition is really important. When you hear the word X, as a X something is approaching the Bering Sea, we have a storm that started life as a tropical system, but the wind field is going to grow, and that means it's going to be bringing warm air north with it. And so Halong, for instance, on Alaska, got to 68 degrees on the east side of that storm as it was passing through the Aleutians, all-time record high for the month of October. So X just means started life as a tropical system and has transitioned to a more conventional source of energy. Okay, here's a track of Halong. Here's Japan. We're up there. We're right near that 64 there. The color field here is the ocean temperature difference from normal. So what strikes me on this is there is almost the entire Pacific Ocean is red, so warmer than normal. Here's the scale. And notice that Halong, after it made the turn, passed right across this area of maximum guess I should use the pointer here, right? Passed right across this region of highest temperatures relative to normal. But even through the Bering Sea, sea surface temperatures well above normal. In fact, didn't get to below normal till it got up over the ice in the Beaufort Sea. So really, that is an important factor in this. And let's see what else. Oh, the other thing I wanted to point out on this, the maximum intensity of the storm after it had passed Japan occurred when the storm was just offshore of Ammonic in the Yukon Delta. And you can see this is here to that dot in the Beaufort Sea. That's a 24-hour movement. This storm was rocking. Once it accelerated away from the Pribilofs, this was moving really, really fast. Probably as bad as the outcome was in the Cusco Delta, that forward speed probably meant it could have been worse had those strong winds been in place in any one spot longer. So here's the computer model this is not a forecast per se. This was what the model thought the actual conditions were 4 a.m. on Sunday. And this is just heartbreaking. You'll notice these purple colors, that's sustained winds in excess of 50 knots or 58 miles an hour. We see this not infrequently over the open ocean around Alaska, but this is on land. And you can see Kipnuk here, Quig just to the southeast. They're right in that belt. The whole YK Delta up to about Chivak there, in those extremely strong winds. This time the reds there, so basically gale force winds, were extending north into Norton Sound. But this is just a heartbreaking because we knew, at this time, the first videos were starting to come out from those communities, and oh my gosh. Now, why if you're a weather watcher in Nome, this may have struck you too, but this track of a storm this strong, basically shooting the gap between St. Lawrence Island and the Yukon Delta, that is an extremely rare track for a strong storm to take in the autumn. In fact, we could only find one other storm in the last 75 years in the autumn that was at this depth or less, or even stronger, that took that trajectory. That was in mid-October 1987. It also produced flooding on the Cusco Delta, but did not, of course, produce flooding at this magnitude, which is beyond anything in living memory. The other thing that we have to worry about. So this is the third typhoon since 2022, or ex-typhoon by the time it gets here, that has moved from the North Pacific into the Bering Sea and then beyond into the Arctic. Merbach, of course, in 2022, ex-typhoon Ampil last August. That was in the western Bering Sea, didn't produce coastal flooding in Alaska, but it did produce very strong winds. That was the storm that produced here in Nome the strongest summer winds in decades. And now Halong. So 3 in 4 years. The thing that I'm concerned about is having gone back through the ex-typhoon records of typhoons that have impacted Alaska. Those, of course, are not particularly uncommon, but they mostly impact the Western Aleutians, less commonly, but sometimes the Eastern Aleutians, and more rarely the Gulf of Alaska coast or even Southeast. However, going back through the 1980s, 1980 to 2020, I can find a grand total of 0 ex-typhoons that took this trajectory: North Pacific, Bering Sea, Arctic. And there's more than a dozen typhoons that have affected some part of Alaska in that time. So, once Merbach, okay, that's interesting. 2, okay, we can chalk that up to coincidence. 3 now, we got a problem. This is something that we need to investigate. Is this a response to the autumn warming of the oceans and loss of sea ice? That's a research question. We don't know. But 3 times now in 4 years, this is worth looking into. I wanted to show this here in Nome because we were really concerned that this was going to be calamitous for the Seward Peninsula and eastern Norton Sound. And this is the same graphic that was in the Nugget, except since I'm showing it here, I can put color on it, so I think it makes it a little easier to read. The red is the actual track of the storm. The X's show the forecast position of the storm from the weather models on Thursday, October 9th morning. And so these are paired like this. So for up through the forecast up through Saturday evening from Thursday, we're actually pretty good. The X's are pretty close to where the L's are. And then things went sideways. The storm accelerated. So this is the observed 4 a.m. on the 12th. This was the forecast position and not nearly as deep. Here, northeast of Nome. Here, southwest of St. Lawrence Island, in actuality, northeast of Kotzebue. That is a major, major bust. Also, the intensity was way over forecast. This kind of track would have been calamitous for the Seward Peninsula. East wind or south winds on the east side of the low would have just plowed this water right up through Bering Strait and right into the coast. And then when the storm went by, those west winds would have swept that into the eastern Norton Sound. That's why we were trying to pull out all the stops. This is a time frame within 2.5 days. The weather models ought to be pretty good. Not going to get every detail right, but this is really a serious miss. And even when the weather models started to pick up, maybe be a little farther east, this is the Saturday morning forecast for 10 a.m. Sunday. This is only a 30-hour forecast. The global models ought to be very, very close at this point. Had the low too far to the west still, and look at these winds. The purple level winds right across Norton Sound, right into the coast, Nome eastward. So even as late as the storm is crossing into the Bering Sea, the models would still had no clue. Well, okay, they had a clue, but because like all coastal areas, slight shifts in track and intensity can radically change the outcome at any one point. This is too far to the west, it's too deep, and because it wound up being farther southeast, that the extreme winds wound up shifted way farther to the south. Really, a difficult situation. But and I certainly did my part to try to let people in the region know. And I'm going to tell you, I'm very glad that it didn't happen, but I'm also very glad that people made preparations. If we needed any reinforcement in this time of change and extremes, prepare for the worst and hope for the best. That we got that here. We did not get that in the Cusco Delta. It was, beyond living memory, bad. So, hats off to everyone that took precautions ahead of time. And I'm glad in this region that it didn't wind up being too bad. Although there was a lot of wind damage in eastern Norton Sound, even in places that get a lot of wind, like Unalakleet. All right. Any questions about Halong stuff?
First, to comment that I think people really did take your warnings to heart. Drove down the coast a day or so after Halong, and there were beach cabins parked, removed from the beach and put up in gravel pits. People we're trying to be proactive and put that to heart. And look at Shack 2 Lake evacuated, and
I was so happy when I heard that.
yeah, that was very impressive. But so not so much about long, but so when a typhoon transitions to a more temperate type storm with the surface flow, does it appropriate a smaller system, a surface system? Is this tropical system comes in, do they combine and turn into something, or is it just morphs?
Usually it morphs. I mean,
Yeah.
you could probably find examples where
Yeah.
one low got absorbed by another, but usually it's just a morph.
Yeah.
And most of the time, that transition from tropical to not tropical is just a short step on the way to dissipating. Most of the time, the storms don't go on to have major impacts. Usually they go on to die. But as we've seen once in a while, that doesn't happen.
There is a question online. Go ahead, Claudia.
Yeah, hi. My question is, I was looking at some online wind maps and I saw that when Halong moved north along Kamchatka, there was a huge low outside of Kamchatka. And it looked like that was interacting with that low in some form, maybe siphoning energy off of that low. Is that something that happened? And would that have influenced its path further to the east?
No, you can see on the track map there, Halong was never very close to Kamchatka. There was an old system back there, back towards really the Kamchatka coast, as you noted, but I don't think there was any interaction there.
Oh, okay. Yeah. All right.
All right. Any other questions before we continue? Online or go ahead, Sarah.
So, going back to the X part of its description.
That one?
From what I understand about typhoons, and what you said, I'm sorry I arrived late, but they generate their energy from warm water.
Right, from warm ocean water.
And so when it begins to generate its energy from air
temperature difference.
temperatures, then it gets that X typhoon label attached.
Right, if it had been named, then once it's drawing its energy from air temperature differences, then it's no longer tropical, so it gets the X
So
label.
did wind speeds, you said they increased, or they just got more widespread once that transition happened?
So the wind field always expands.
Okay.
In this case, the winds in Halong never approached what it was at its peak as a typhoon just east of Japan. Merbok was the other side. Merbok was barely a typhoon for 24 hours. And as it deepened dramatically as it made that transition, and by far the highest winds of that whole system were in its X phase with 80, 100 knot winds over the western Bering Sea.
And you mentioned something about research too. About why this is happening. Potentially with whether or not it's correlated to climate change. Is that part of the discussion? Is this something that we think could be connected to climate change, or we just don't know still?
It's clearly when we're talking about the movement of these systems, that becomes very complex. The fact that oceans are warmer, there's more water exposed in the Arctic because of the loss of sea ice, that certainly by itself could contribute to intensity and precipitation. With X typhoons, that could certainly be part of the reason for how these systems are developing. That extremely warm air that Halong brought north with it. Some of that reflects its tropical origin, but then it was passing over North Pacific that was so hot already So it didn't cool off as much. And that then increased the temperature difference of the storm that the storm was feeding on, just because it brought its own superheated air with it. But this track thing moving from the North Pacific through the Bering into the Arctic, that there's no one-to-one correlation there between warming sea surface temperatures and decreased sea ice. That could be a factor. It's been in the news some about the increased waviness of the jet stream under climate change. However, that's usually talked about as a wintertime phenomena, not so much in the autumn. Hence the research part.
All right, I think we'll end this section and move on to the 2025, but Wes Jones has his hand up. So go ahead, Wes.
Oh, while we were still on Halong, I was just going to make one comment from down here in Unalakleet, is that it seemed like we were really surprised at how well the wind forecast was. It followed perfect, and then to have the flood stage water forecast different was really wild. But the one really kind of interesting thing that happened down here is we've had winds like this, but I think it has to do with how much rain we had prior, the amount of trees that we lost along the river, and at different places there's stands of cottonwoods that 80% of the cottonwoods got knocked down, and we have other stands that of spruce trees that 50% of the stand are tilting at 30 degrees now. It's really wild, and we think that a lot of people here think it's because the ground was just so saturated prior to this storm. But anyway, I just wanted to give those comments. So, and thanks, Rick, for all the forecasting. It was greatly appreciated during this storm.
Great, thanks for that info, Wes. That's really important.
Thanks, Wes.
Okay, now to the advertised portion of the program. Nome summer 2025, warmest summer since 2020. Not wildly above normal here in Nome. On the little graphics there, that's the daily average departures for Unalakleet on top and Nome on the bottom. Unalakleet was definitely had a warmer summer relative to normal than Nome did there. For Nome, 82 on July 8th, first 80-degree temperature in a few years, and 30 on the 6th, pretty typical. How about summers through time? So what each dot is the average temperature for June through August every summer since 1907. Important feature of this graphic is I've put that vertical dotted line there showing when the observations were made either in town or for a few years out at Fort Davis, and then the switch to Marksfield Nome Airport. And that matters because it's pretty clear that being in town or Fort Davis, it's a bit closer to the Bering Sea water, and so probably helped keep temperatures down relative to if the observations had been in the same place that they are now. Nonetheless, the change here is very dramatic. The blue dots are the 10 coolest summers. All of them were prior to 1980. The 10 warmest summers are not all bunched up in the 2010s or later, but all but one or two there are since 1980, and there's a clear break there in the late 70s in that step change in summer average temperatures for Nome. Summer rain. So the bottom line there is the normal accumulated precipitation, June 1st, and then it ends at the end of September. And no surprise, the entire summer we were running above normal rainfall, but there were a couple of quite notable spells there of in June into July. Wasn't completely dry, but pretty warm and a little bit of rain. And then in September, of course, we had that long spell with almost no rain The real warm spell there in August shows up nicely as well. But all in all, you can see we wound up with almost 11 inches of rain, and normal is less than 9. Okay, how about the Nome summer precipitation through time? Each bar is a year. Bunch of interesting things showing up here. As you know, most of the last 6 or 7 summers have been pretty wet, including a couple of really, really wet. I do want to point out that you'll notice this year and several years in the immediate past exceed the 10-inch precipitation. Notice how rare that was from basically the 1960s up through the 1990s. Hardly any summers got that much rain. There's a couple, but not very many. Prior to that, 10-inch rainfall summers were more common, and obviously become more common now. That's kind of an interesting long-term variation in the summer rainfall. The black line there is just the estimated average over time. So you see that dip there in the 1970s and 80s. The current estimate of the average is almost exactly where we were back in the World War I era. One of the things that I was hearing a lot was, oh, at least we got some sunny weather this summer, in stark contrast to some previous summers. So here, of course, we have no measurements, long-term measurements of solar energy or sunshine. So here I'm using our climate analysis model that does output things like that. So this is basically for the Nome area. And since 1979, so that's important because that's when satellite data began to be incorporated into this. And I've divided up, if you count the dots, there's about the same number of dots in the cloudy summers, the sunny summers, and then the in-between. We'll call those average summers. And you can see I've highlighted there 2025. And yes, indeed, it was sunnier, or there was more sun this summer than 3 of the last 4 summers, but it was still on the cloudy side historically. So yeah, it was better, but still not the amount of sun, you know, as we had in some of those very warm and some of them very dry summers in the 2000 teens there. So that was kind of interesting to see. All right, how about summer sea ice? Tour through time. Here's the Weather Service sea ice concentration analysis. So we started out summer there on June 1st on the left with still a fair bit of ice there between St. Lawrence Island and St. Matthew Island, mostly on the east side. Also some ice there on western Gulf of Anadyr and a little bit left in Norton Sound. Summer solstice in the middle there. Ice there in the south is all gone. Still just a little small amounts there in the Bering Strait and off of St. Lawrence Island. More ice there in the western Gulf of Anadyr, and that was pretty much gone melted out during the second week of July. Now, I did want to point out a big difference between this year and last year, and that's that ice that we had last year on the north side of Chukotka that frequently sent ice down through the Bering Strait. Most of it stayed on the west side of the strait. I think there was at least a couple days when some of it floated between the Diomedes. This year, nothing like that. The ice melted back from the northeast Chukotka coast kind of late, but when it melted all the way back almost there to south of Wrangel Island. So a much more normal ice season for our neighbors there in northeast Chukotka than last year. And speaking of the oceans, here's our summer, June through September average sea surface temperatures relative to normal. As is become the norm here, the nearshore waters are warm. That's tied to earlier sea ice melt especially. Not much in the Bering Sea here with areas of that for the 4 months were below normal. There's a few there, but certainly the above normals really dominate for that long-term period. Now, this was quite an interesting graphic, and this is the using the highest resolution real-time sea surface temperature analysis data from NOAA, which has a 5-kilometer resolution. So that's really fine grained for a satellite-derived product. And so what we have here is the blue line is this year's sea surface temperatures from that high-resolution product. The red line is last year, and the black line is the 1991 to 2020 average. So we had been mostly running above normal after we got into June. And you can see there the response of the ocean temperatures, some of that warm weather we had in early July. But then we have this massive peak there in early August. And when I first saw this, my immediate response was, that can't be right. Something's gone haywire with this grid. So I cross-checked it with a independent satellite temperature analysis, and no, the values aren't exactly the same, but they showed this big spike in the offshore temperatures at Nome. And most importantly, the HABS team who are doing the sea ice or the sea surface temperature measurements as part of their observations also picked up exceedingly warm waters off the beach here in early August. That almost 65 degrees, that's the highest temperature in this data set for offshore of Nome. Now, it was pretty short-lived, but really quite remarkable. So the highest one day, and also if we take a 5-day average to kind of smooth out some of these peaks, it's also the highest since 1985 when this data set starts. At the very end of this, which goes through late last week, you can see that the sea surface temperatures are back up above normal, and the highest since 2020 for this point in the season. We saw that on the Halong map, the very warm water, driven in part by just the very mild weather that most of mainland Alaska had the first half of October. Now, one of the things that I keep track of, in part to support what's the HABS threat. This is the number of days per season when that offshore area Nome, so 25 to 25 miles offshore, the total number of days that the average temperature is above 10 degrees Celsius or 50 Fahrenheit. And then the black lines are kind of what I call the era averages. So it's clearly ramping up the number of days that are that warm. Last year, of course, was quite an outlier because it was so stormy. We had we had fewer days even than would have been typical back in the 1980s and 90s. This year, we reverted right back to the modern era average. So I think this is quite important, and probably quite important ecologically as well. All right, last part of my section here will be the upcoming winter outlook. All right, so NOAA has declared that we now have a La Nina in the equatorial Pacific, and will this play a role in our upcoming outlook? Well, here is the sea ice outlook. This is from the NOAA experimental seasonal sea ice model system. And this is one of my favorite products out of that. So one of the things that comes out of that is when does the first ice of the season show up? Not that it stays, the first day when sea ice concentration better than 15%. I've binned this into half-month intervals for you and labeled some of the ones on the map there as well, just to make it easier to interpret. So you can see here in this forecast, which was made in late September, this is only run once a month. So the next update will be next week. You can see in the Chukchi Sea, we keep open water over a fair chunk of the offshore areas there. through the second half of November, ice, although there's a small area there offshore of Shishmaref, that the first ice isn't until the first half of December. You can see though, ice in this model is first ice of the season down to St. Lawrence Island. The first half of December makes it down to St. Matthew Island the second half of January. Now, if you look close here, you'll notice a couple of howlers. One, Kotzebue Sound did not have their first day of ice in early October, nor did Norton Bay. That's not surprising. That is a problem with this model. It's really designed for open water. It doesn't handle small bays and shallow waters very well. So no, yes, that's an error, but that's a common error. For the open areas, which of course, we really need that Chukchi Sea to ice over before we can get substantial amount of ice south of the Bering Strait. This kind of timing would be similar to what we've seen in most recent years, obviously a lot later than what was typical in the later 20th century. All right, Climate Prediction Center's forecast here of temperature and precipitation. So for November through January, the early winter season, we have across Western Alaska a tilt to favoring significantly above normal temperatures. Notice that below normal tilt across Southeast. That is kind of a classic La Nina pattern, although not necessarily classic this early in the season. If we look at all the La Ninas since the mid-1970s, it turns out for November through January, knowing that it's a La Nina tells us nothing about what will turn out in Western Alaska. And in fact, for most of the state, it doesn't do very well. So some of this forecast is based on the expectation that relative to the 1991 to 2020 period, sea ice would come later. Precipitation above normal is the tilt there across the Bering Strait region and all of Western Alaska. No real surprise there. That's been a good bet for a forecast for frequently at the seasonal scale here for us, and being fed by that later development of sea ice. And for the midwinter season now, so December through January, you can see not really much change for Western Alaska. Notice though that for the northern Seward Peninsula, Bering Strait region, the Climate Prediction Center has really pushed up the chances of the seasonal average being significantly above normal, 55% chance of that category. So that's a really aggressive forecast by the Climate Prediction Center. For Nome and Eastern Norton Sound, the tilt is not quite as strong. No change in that precipitation favoring about 2 to 1 likely, significantly above, about twice as likely as significantly below if this is an unbiased forecast. And that is what I have for you, and I'm going to turn it over to Anjali, who's going to talk about our extreme events library.
So save your questions until the end. We'll go right in with Anjali.
Well, thank you, Rick. As mentioned, my name is Anjali. I'm the Alaska Fellow with ACCAP. I'll be working with Rick for the next 8 months on the Historic Extreme Events Library. I will explain what that is the next slide. A little bit about me. I just moved to Fairbanks from Massachusetts in September, and I studied oceanography and applied math in my undergrad. So I've always been really interested in studying how environments have changed and how kind of past observations can help us prepare for the future. I've also never experienced an Alaska winter, so got any tips? So an outline for what we're going to talk about. We're going to talk about what the Extreme Events Library is. We're going to talk about some new technical improvements. We're going to do an event spotlight. So I've been working on kind of chronicling the history of coastal flooding in Nome, and then some future steps. So what is the Historic Extreme Events Library? It is located on ACCAP's website under resources and projects. And right now it's just kind of, it looks like 12 flyers, and they all aim to clearly chronicle and communicate the impacts of extreme events on Alaskan communities. So what do we mean by extreme events? Really any environmental change that is significantly impacting a community. So it can be storms like the 2011 superstorm in Merbach, can be avalanches in Southeast, North Slope sea ice changes, interior breakup flooding. We have one on Fairbanks wildfires kind of over time. So really any of those changes. And if this concept sounds familiar, that's probably because Caroline Erickson, who was the fellow in 2023, did present on this at Straight Science probably exactly 2 years ago today. So this is one of Caroline's flyers, and I just kind of wanted to show you guys what a good example of the documents looks like. So this is the 2011 superstorm, and on the left, you can really see that there's a lot of kind of weather data. Where was the storm? When did it hit certain places? And there's pressure readings. But then on the right, we have this is really the focus of the project, is these community specific impacts. So looking at infrastructure damage, looking at were there evacuations? How did the community respond? How did the community feel after this? And these are really kind of hyper-specific impacts that we can only gather from local newspapers. And so the idea here is we have this interdisciplinary process. We're looking at NOAA weather data, we're looking at FEMA disaster declarations and sometimes scientific papers, but we're also really diving into local newspapers, in the case of NOAA, usually the Nugget, to really make sure that we have like a full story of what happened during every single one of these storms or coastal flooding events. And so this is just kind of a new technical aspect of the Extreme Events Library. Right now, if you go on that website, you kind of have to download a document to be able to read it. So in about, I would say probably 2 weeks, you'll just be able to click on whatever event you want to view. You can download the document on the left there if you want to, but you can also read all the information that's on this document just on a web page. So that just makes it a little bit more accessible if you don't want to download a document onto your computer. And you can read all the same information. It may be slightly less like aesthetically pleasing, but maybe more accessible if you just want to quickly scroll and learn about the impacts of some specific event. So one of the new events that Rick and I have been working on is coastal flooding in Nome over time. So this is kind of one of our category events. So it's not looking at one specific coastal flood, but just looking at history of coastal flooding in Nome. Our goal here is to document the impacts of coastal flooding in Nome and kind of how and why these impacts may have changed. This was all very inspired from Carol Gale's Western Alaska Interdisciplinary Science presentation. So thank you for doing that work. For those of you who didn't see it, it was entitled Old Nome Spirit, and essentially took a lot of information from Nugget archives about how about basically Nugget archives during specific storms. I believe she started in 1899. So that was kind of our inspiration, and also provided a really helpful baseline for our research process because she already had pulled out a lot of that information. And then we also looked at, like I said, NOAA storm archives, FEMA disaster declarations, occasionally some peer-reviewed literature. So that kind of looks like this on your desktop. There's a lot of information from a lot of different sources, but eventually this turns into this. And so this is the final document. It's about 4 pages, and I want to make sure you guys have time for questions. So I'm not going to go over it in too intensive detail. But if you do have any questions, or you really want to view the document once it's been released, you can feel free to send me an email, and kind of once it's done, I will send it over to you. So this is the first page. We have a couple pictures from KNOM and the Nugget, and then we also have kind of an overview of Nome, and how, kind of just describing how Nome became a certified NWS storm ready community, and how the region has been tested, of course, by so many coastal flooding events over the years. And then we have kind of a weather facts section that's courtesy of Rick, talking about, of course, Nome is exposed to a lot of the Western Seward Peninsula in general is exposed to 100 miles of open water, making the area vulnerable to flooding. That's mostly for, I guess, people that aren't aware of it. And then this is the timeline. So obviously a lot of information on here, can't go into all of it in too much depth. I guess the main takeaways here are that the timeline combines information from the Nugget and a lot of NOAA storm reports. So the idea is here you can get some statistics about, for example, like how high the water was or the fastest wind gusts, but you can also get information about like what streets were flooded. So yeah, for example, like in the 1913 storm, we have like River Street flooded and the Snake River Bridge destroyed, which are kind of pretty specific impacts that hopefully are relevant to you guys as members of this community. I just have a couple things I want to point out on the timeline. So we have two examples of kind of these doubleheader storms. So in 1902 and in 1946, there were two storms in the fall, and especially that second storm in 1946 really had a significant kind of archival impact in the Nugget. Like you really see people talking about it. And that's kind of why I guess there's a little bit more information about those storms, really to kind of document that proportional impact on the community. And of course, shortly after the 1946 doubleheader, the seawall was constructed. So that's just kind of an interesting, I guess, timeline to put together as this archive comes together. And then we also see this really kind of high frequency of storms in 2004, 2005, and 2011. Three really big storms hit this region. And right after the 2011 storm, Nome did become kind of certified storm ready by the National Weather Service. So that's just kind of another outside event that's not necessarily on the timeline, but just interesting to think about in the context of kind of all the information that's on here. Yeah, and then the last page is about the role of sea ice. So obviously sea ice is a natural buffer for those of you who might not know, and it essentially kind of decreases wave energy, which protects the coastline. And there was a recent study done by ACCAP, which was showing the sea ice season in Nome. So for this graphic, each vertical line represents the length of the sea ice season. So the bottom is the freeze update, the top is the break update. And as you can see, the freeze updates are getting later and the break updates are getting earlier. And then the red bars represent years that correspond with significant coastal flooding events. So these are going to be the 1992, 2004, and 2011 storms. And you can just kind of see that those red lines are really correlated with years of late freeze up. So that's just kind of an interesting, I thought the way that graphic was communicating that was just kind of particularly interesting and clear. Really, we can't say anything for sure, but it's definitely indicating a potential correlation there between that late freeze up and coastal flooding events. So another kind of, I guess, personal interest of mine is harmful algal blooms, obviously an emerging hazard here. So these are caused by Alexandrium cantonella, which are a species of phytoplankton dinoflagellates when they rest on the seafloor, and when certain conditions arise, it's not completely clear what those conditions are, but likely warmer conditions with potentially specific salinity conditions. They rise to the surface, they bloom, they can produce paralytic shellfish poisoning, toxin, which can make you sick. And so the goal of this project is to create a comprehensive timeline of HABs all over Alaska, so in the northern Bering Strait region, but also in South Central and Southeast Alaska, where this has been a really prevalent hazard for a really long time. So kind of document how HABs impact different Alaskan communities and how communities may have to respond differently based on their infrastructure and like personal history with this hazard. So I've been going through a lot of literature to look through to kind of make this timeline. So far I have 66 HAB events that have happened in Alaska since, I believe it's 1970. And of those 66, 7 of them are occurring in Western Alaska, and 6 out of those 7 are within the last 8 years. And even the one that's not in the last 8 years, that's 2012. So it's not to say that this hasn't happened before, but the record of HABs in Western Alaska only starts really recently. It only starts like around 2012. And so that's kind of saying a lot about potentially the data collection efforts here. There haven't been a lot of them, but it's also saying that there have been a lot more data collection efforts in the past 10 years, and that is really good for that kind of monitoring, especially in terms of community safety. I'm sure you all know about the 2022 HAB event, which was the largest, most toxic event ever recorded in the US, and it occurred in the Northern Bering Sea. There was also the same instrument that collected that 2022 HAB detected HABs in 2018 and 2019, kind of in the Northern Bering Sea region as well. In 2021, there was a herring kill off of Kotzebue, which was tied to saxitoxin after analysis. And saxitoxin is the toxin that's produced by those phytoplankton. And then in 2023, there was also a HAB detected in the Northern Bering Sea by a passing ship. But you'll notice that a lot of these efforts are not super specific. A lot of them are detected by passing ships rather than super specific water sampling efforts. So I kind of just wanted to highlight that as a pattern that exists in the Western Alaskan data that doesn't really exist elsewhere. These records in Southeast and South Central are really hyper-specific. They tell you what beach you can and can't fish at. They tell you when you can stop and start again. And that's just something I kind of wanted to highlight for all of you. And yeah, thank you. And feel free to contact us. And
Great.
happy to take any questions. And then do you want to talk about a thing tomorrow?
Yeah, before we get to questions, so thanks very much, Anjali, and Koyanak, all of you for being here and participating. Tomorrow, open mic day at UAF Northwest Campus. Anjali and I will be here 3 to 6, and we would love to have anyone that's interested. If you're in the room, if you're online and know, stop by, and we would love to chat with you about anything, weather, climate, environment related, something you'd like to know, something you think we should know. Come on down. We would love to hear what you have to say. If you have questions, we'll do our best to answer, but we really want to hear what you think, whether it's about storms, whether it's about the increasing HAB threat, whatever it is, we'll be here. Open mic day at UAF.
And the conference room, if you want to come down, the conference room in the community outreach building will be the place. There's an AC meeting here tomorrow, and you can take a break from that AC meeting. Come on over, Charlie. But the community outreach building is if you go through this main building north and get on the boardwalk, just the next door to the left.
And will we have a sign on the door?
Yeah. And there's some handouts there to remind you that's needed.
Okay.
All right.
Right.
Well, thank you. Before we take any questions, this is the time, at least online, while you're thinking of your questions, to give Rick and Anjali some love in the chat. It's never easy being a straight science speaker or a public speaker, and well done. And we thank you so much for taking your time to come out here in person and get her done. You're getting lots of claps, which you can't see on the screen. Oh, look at that. Recorded. There's a ton. Well done. And they keep coming. Hi, Polly. And so with that, we'll take any questions you may have. Anybody in the room here? No. Sarah got it up there quicker. Sorry, Charlie.
Hi, so, the historical data that you pulled up about the coastal flooding is predominantly from the Nugget.
And the National Weather Service storm record as well, but those only start around say 2000.
I just wondering, did you have any plans to potentially incorporate like more traditional stories that you come across, or anything that might document things and that can pass from communities, or from the communities based on what they observed or what they stated through stories? Or is there any information out there that's published, that we can access? That just maybe brings another perspective into this picture?
Yeah, so tomorrow, that is the goal of tomorrow, a
Oh,
little
sweet,
bit.
okay.
So that would be great. Anyone with stories, especially about storms. I think there's talk of maybe adding kind of an audio component to that webpage that I was showing you, because since we're transitioning from the files, we can do kind of more forms of media on the web pages.
Cool.
So I'll have like recording equipment tomorrow if you want to say anything. Or if anyone wants to say anything of that kind of that vein. Yeah.
And that's a good point, because we were talking earlier today, the harmful algal bloom issue, though, is something that I don't think the research community has delved into what our regional history might be or might know, especially if we were allowed to speak freely with our neighbors to the west. We've got that really rich current coming through that's like a feeder for some of this harmful algal bloom action. So, yeah. And Charlie, you had your hand up.
Yeah, I got too many thoughts in my head. So
Go for it.
I have vivid memories of the Omega Block and a super cold event that occurred, I forget when, late 1980s.
1989.
Yeah, and so anyway, there's that, and then, you know, the 1974 storm damage was exacerbated by the shelf ice breaking up and forming a battering ram and knocking out Front Street with the wave action, and so that, you know, ice does buffer, but not always. And I have a meeting in this room when you guys are having your meeting. There's a Russian explorer that came into inventory of the fur resources of Western Alaska, Zagaskin, Lieutenant Zagaskin. And he told an interesting story where he met an elder man down in the vicinity of Safety Sound, who told a story about an extreme fall storm, and the village was overwhelmed by water, and his father threw the lid off the family Barabra, grabbed and happened to grab him by the hair and jerked him out as the water flowed in and drowned everybody else in the house, and he ran for cover and they survived. But so there's an extreme weather event that in the November timeframe, that 1870-ish, pretty terrible storm. But that's only, and then I too have done a lot of research up at the museum, and the museum has quite a photo collection of storm damage starting in about 1900. And really cool pictures and therefore some information. But yeah, I guess my comment was that, one more comment. So it's November 17 is kind of the jinx day for Nome. If you're superstitious, that there's a lot of bad things that happen on that day. Fires and storms, and often the weather, you know, causes fires to get out of control. Go crazy.
I'll put it on the calendar.
Just a follow up on your comment there on the 1870s flood. You know, that is a very fertile area for anybody who wants to do a graduate level project, mining old records for weather and climate events. You know, in the say pre-1880 or maybe 1900 would be a very valuable project. For instance, there's now my mind's blanking. The Canadian traders that had stores set up.
Hudson Bay.
Hudson Bay, thank you. somebody found, the Hudson Bay person that founded the trading post at Fort Yukon found his diary from the 1850s, and we've been able to extract breakup dates for a couple of years from the 1850s. This kind of stuff, of basically stories recorded long after the fact, that were not, they weren't really part of why these people were doing this, but there's a lot of that kind of information, I'm sure, hidden in these old sources that could be extracted and to help extend the record back. You know, that's been done for instance, summertime temperatures with tree rings in this region. And so the traditional stories about the years without a summer, or the summer that started and then stopped, some of those, you know, we can actually pinpoint to the year based on tree ring analysis from the Koyuk area. So there's a lot that we can know before the settlers showed up with their thermometers.
In the 90s, I was doing some prospecting for a oil company up by Quartz Creek up the Cougar Road. And there's a cut bank where, well, when we were drilling down, we drilled down 150 feet to 200 feet, we get frozen logs, chips that come up. And there's a cut bank with some trees sticking out with spruce cones. And if somebody wanted to look at those tree rings, I don't know when that would have been, a long time ago.
A long time ago, no doubt about it. And, but you know, okay, so you're pulling up identifiable bits of tree.
Yeah.
That means that stuff has been frozen.
Yeah, frozen wood chips would come up. It was an air drilling, so we bagged.
So yeah, so that's there's all kinds of environmental information there.
Did you come and date that?
Potentially, sure, why not? Anything online?
No, everyone's thanking you. I have a question. So one, for me, this near miss we just had with that, how long, kind of really put the fear in me. One, we're getting these, like you mentioned, boom, boom, boom. Two, I didn't know what X stood for, so now I'm going to keep out for that. But the fact that people prepared here, I think we've experienced the Murbach, we've experienced those things, and I think when you say it's going to be bad, we all kind of react to that. I think we need to keep that up. I now look at what happened to the poor people of the lower YK Delta, and I think, is that going to be Shishmaref in a year or two? Is that going to be Stebbins and St. Michael's? I mean, now you see these giant ocean surges, and it's hitting us rather frequently, or the Western Alaskan coast. So I just wanted to say that, like, I appreciate all that you and your group do for this region and for getting the word out, and also how grateful I am that people are taking it seriously and preparing. Even though we didn't get it, we were ready for it. I think, Charlie, you mentioned that. My real question is, you often see a lack of public services out here in rural Alaska. Is there anything that we had available through the National Weather Service or other instrumentation that was not working, that would have made a difference regarding this thing is now turning? Or is there something we really need? You know what I'm saying? Was something not there? We often deal with broken equipment here in the region. Things aren't, we have it in the newspaper every week, what stations are offline in which village, and it changes, right? They fix some and then 4 more go down. Is there something that we already have that would have helped that wasn't working when that thing went right and drove right into the YK Delta? Or is there something we need?
So the big thing, of course, and you probably may have read this. So there's been a substantial loss in upper air weather balloon observations in Alaska, and all of the losses are in Western Alaska. There hasn't been an upper air observation from Kotzebue since February. There hasn't been an upper air observation from St. Paul since August. Along went just to the west of St. Paul. Bethel and Cold Bay are, instead of doing 2 upper air observations a day, which is the standard, are doing 1. Very inconveniently, Nome has had intermittent communications problems with the upper air data, and during the week as Halong was starting to approach Alaska, there was 2 full days with no upper air from Nome. So it's inconceivable to me that much missing data in the days and hours preceding Halong had no effect on the models. Whether if we would have had that data, it would have shown this turn sooner, we don't know. There are techniques that we could assess the likelihood that it probably wouldn't have made very much difference or might have had a major difference. There are techniques that we can kind of fill out that spectrum, but because we don't have the data, there'll never be a definitive answer. The obvious question you're asking is, okay, well, why has there been this sustained loss of upper air observations? This is entirely a Weather Service staffing issue. So that is the one big thing in this case that really, if there's ever going to be a clear case of how not having those upper air observations in an area like Alaska, where there's already many fewer upper air observations in the lower 48 or southern Canada, this is it. You know, the eye of the storm went 50 miles west of St. Paul, and upper air data then and leading up to it surely would have had some effect.
Yeah,
We just don't know the magnitude of the effect.
thank you, because this storm took life, you know, this was one where it made a difference that those poor people down there had no idea, or we were all expecting it to come, and then it just went east and slammed into them, and it just seems like, was it something we could have, is there something that we could have better? So you've explained that upper air data. How about our weather stations in the Bering Strait region? Would that have at least given?
That may or may not have helped the weather models, but it's certainly every airport weather station that's offline. That means people in the community don't have that. Forecasters don't have that information. So, so certainly all of that is important, whether it's important to a weather model or whether it's important to the communities and their confidence in what's happening. All of that matters in these extreme weather events.
All right, thank you. I have another question because I like the weather, but for the La Nina, you said we shouldn't feel there. So they're saying it's going to be a La Nina winter. Do you have any tricks up your sleeve? Does that mean we're going to get storms going into Gulf of Alaska more, or will storms, what is it? Is there any kind of no rhyme or reason to a La Nina for our weather, or is it our temperatures go up and down? Or I thought there was something that we had that.
So historically in Alaska, winters when there's La Nina in the equatorial Pacific tend to feature lots of variability. So it might be a few weeks when it's really cold, and then a few weeks when it's really stormy and warm, and they can switch that way several times. The problem that we have right now is that in 2023-24, we had one of the strongest El Niños of record. And what happened in Alaska, including Nome, was nothing like what we would expect in a very strong El Nino. Last year, we also had a weak La Nina, and the weather was nothing like what we would expect in a La Nina. It's a good reminder that one, El Nino, La Nina is just one factor in a complex system. But I'm convinced that the global oceans are so warm now that that's increasingly confounding what had been at least a moderately useful tool. And so maybe lowering the importance, especially here in Alaska at the north edge of the Pacific. Things did work out more or less as you would expect in places like California, but not so much here.
Any other questions? Nothing? All right, and I think we're all set for the audience. So we want to say thank you to Rick and Anjali, and I would normally say stay a few minutes after, but online, but since you're here in person, we'll do it in person. So thank you all again for giving us this opportunity to learn more and ask our questions. Thank you so much, both of you.